Angela, let's start. Let's also put that away. There we go. Thank you. We just finished a unit on kinematics graphs, motion graphs. And graphs are nice, they're visual. They're a pain though because they're, first of all, tough to make. It's always a pain drawing a graph. And they're inaccurate in that you can only read points that cross a grid line. If it's hanging in midair, generally we're having to guess. So we're going to repeat a lot of what we've just done, but we're going to do it more efficiently in this unit. We're going to be using equations and math. If you've got a mathematical bent, you'll really enjoy this. If you don't, you'll get much better at math by doing this. We're going to talk about acceleration. Finally, we're going to let you press down the gas pedal in the car. I haven't really been able to do that yet. I've had to have everything go at a constant speed, and it's been boring. Acceleration. Acceleration is, well, it's defined as the rate of velocity change per second. It's how fast your speed is changing. If you're accelerating faster, your speed is changing faster. Doesn't mean you're going faster, it means your speed is changing faster. In this section, we're going to be looking at constant acceleration, which means our velocity change per second will be constant. And the units for acceleration are meters per second, which we write meters per second squared. It will, well, for the rest of the year in particular, become worth it memorizing what units go with what concepts. It really cuts down on your thinking and mistakes. Acceleration is a vector, has direction, but it's difficult to visualize or interpret its direction. I'm going to give you, though, a clever hint in a little bit. And the difficulty in visualizing acceleration is we tend to confuse it with velocity. The direction an object is moving and the rate at which it's moving are both related to the velocity, but not to the acceleration. You can be moving north and accelerating south. You'd be slowing down. You can be moving south and accelerating north. You'd be slowing down. You can be moving north and accelerating north. You'll be speeding up. But it's really tricky to separate the two. To determine the direction of the acceleration, we need to watch the object for a period of time and see how its velocity is changing. We're going to do one example longhand, and then we're going to say, please God, let there be a shortcut. So we're going to get all direction-y here for a little while, and then we're going to do a better way. Suppose the acceleration is positive 1.25 meters per second squared east. What direction? East. Again, what direction? East. And we're going to do 3 examples. Your initial velocity VI is 0. Your initial velocity is 2 meters per second east. Your initial velocity is 2 meters per second west. So you ready? We're going to do a chart. Here's the first chart. I think I can go a little larger. So in example A, Simi, what did I say I wanted my initial velocity to be for part A? So let's all put a big 0 meters per second right there. And since it's 0, adding a direction doesn't make much sense. Okay. But which way are we accelerating, Simi? By how much? Every second, our speed is changing by 1.25 meters per second in the east direction. So if we start at 0, after 1 second, we're going to be going 1.25 meters per second east. How fast will we be going? If our speed changes by 1.25 meters per second every second, how fast will we be going after 2 seconds? Think you can do it in your head? Yeah. 2.5. You have to even add a 0 there and go to 3 sig figs consistently. Meters per second east. What about after 3 seconds? How fast will we be going? 3.75 meters per second east. What about after 19 seconds? Do I have to find the next 18 to do the 19th? No, and we're going to find a better way to get there, but we're going to start doing this longhand first. Is that okay so far, Connor? By the way, after 4 seconds, I'd be going 5 meters per second east. That's if we start at rest. What if our initial velocity in part B Connor, what does it want us to start out in part B? Okay, so let's start out with 2 meters per second east. Which way am I accelerating? Also east?
Yes.
By how much? 1.25 meters per second, or meters per second squared. So how fast will I be going after 1 second now? Loud and proud, you're right. Direction? What about after 2 seconds? Our speed is still changing by 1.25 east, and we're already going east. 4.5 meters per second east. What about after 3 seconds? Spotting the pattern? 5.75? Good. Meters per second east. Okay, now it's going to get a bit trickier. We want to go 2 meters per second west. Okay. What would be another way to write that so that I had east here? How could I write 2 meters per second west as east? Yeah? -2. I think it might be handier for us to think of it as a negative and our acceleration as a positive. Now that I've done that, how fast am I going after 1 second if I'm accelerating 1.25 meters per second east? Yeah.
-1.75.
Careful.
Or sorry, 0.75.
Do you hear him? He's saying, I think now you're still going west, but you're going 0.75 meters per second west. But it's probably easier mathematically just to think, oh, I'm starting at -2 and I'm adding positive 1.25. So you can also think about it as negative 0.75 meters per second east, which would be west. Okay, now the trickier part. How fast am I going after 2 seconds? How did you get that? Direction? First of all, you said seconds, meters per second. So 0.5 meters per second. Direction? East? How'd you get that? Subtracted? And it's easier to add to the negative. Like, it's easier to do it mathematically, to go, well, negative 0.75 is what I started with, and I'm going to add one positive 1.25. What'd you say it was? 0.5, I'll even add an extra sig fig east. And I can only write that one way. I'm not going to do an or, because... By the way, what direction were we going after 1 second still? What direction are we going after 2 seconds? What must have happened between 1 and 2 seconds somewhere? I must have come to a stop for a split second and then changed direction. Must have turned around. Must have turned around. Have to have. Okay. After 3 seconds. What about after 25 seconds? Do I have to fill in the next 24? Oh, I hope not. So I wrote here, there has to be a better way to do this. Please let there be an equation. There is. Probably the equation that most of you will end up memorizing because you'll use it, probably 400 or 500 times during the year. It's on your sheet. Don't worry about it. But this is one of the, again, the only reason you should memorize something is because you get sick of looking it up. And most of you memorize this one. What's the equation? Well, we have to start out defining some stuff. So acceleration, whenever a velocity of an object changes, the object experiences acceleration. So if your velocity isn't changing, if you're at a constant velocity, what's your acceleration as a number? 0. That's going to come in handy later on. Acceleration is defined as follows. It's the change in velocity over the change in time. Except we have an abbreviation for change in. Delta V, and I'll put the vector sign above the V because it is a vector, over delta t. Symbol for acceleration, we use a lowercase a. The units, well, v is measured in meters per second, time is measured in seconds, so it's sort of, don't write this down, it starts out as meters per second, but really what we're saying is, hey, there's two s's on the bottom, that's a meters per second squared. Scalar or vector, does it matter which way you're accelerating? Will that change the question? Absolutely, it's a vector. Velocity has the same symbol as speed, v. That's a speed, that's a velocity if I add the vector sign. If the velocity at the start of the time interval is vi, I stands for initial, and the velocity at the end of the interval is vf, what do you think F stands for? Final. Then the change in velocity will be final minus initial, v final minus v initial. And if I do the same thing for time, if I call it time initial and time final, then the change in time is going to be tf minus ti. So I can take this equation up here and I can write it like this. Although we get lazy because time is always a change in, over the years we've stopped putting a delta in front of the t. If you see a t by itself, it is a change. Because the only way you can possibly measure time is to start a stopwatch and start a stopwatch. And we'll assume you start the stopwatch at 0. Because why wouldn't you? Oh, where the triangle is shorthand for change in or interval. Little handy note. Change in anything is always final minus initial. If you want to find the change in voltage, it's going to be the final voltage minus the initial voltage. If you want to find the change in momentum, it's going to be the final momentum minus the initial momentum. If you want to find the change in, if you see that triangle, find the final thing, find the initial thing, and subtract them. That's going to be handy. Okay. Velocity is a vector, so it has two aspects to it. Speed, its magnitude, and its direction. It means you can accelerate if your speed changes, if your direction changes, or both. In Physics 11, we're mostly going to be looking at situation A. We're going to be pressing the gas pedal down. We're not going to be turning the steering wheel very much of the car. That also means you're accelerating, but that's Physics 12. All right. Whoop. Let's do a question. A runner is racing in a 100-meter dash, and he accelerates from rest. All of us right now, let's underline the phrase from rest. That's a key trigger phrase. To a speed of 9 meters per second in 4.5 seconds. What's his average acceleration during this time interval? What does this question want me to find? I'm going to write down A equals question mark. By the way, the reason I said average acceleration, I've watched runners, they don't accelerate at a constant rate, but we can't handle that. So if I ever use the phrase average acceleration, you can sort of ignore it. It's me being fussy saying, I don't think the acceleration is constant, but we're going to pretend it's constant because that's the only math we can handle anyways. Okay. What's that 100? What's that 9? Which velocity? Do I know that? Loud and proud, someone said it, they're right. Jenna. Okay, from rest, 0, and that's going to be very important. In fact, you're going to find, Jenna, I have a habit whenever I see the phrase rest or stopped or from rest or at rest in a question, I'll underline it because it gives me a 0 somewhere. What's that 4.5? Well, that's actually the change in time because your start and stopwatch would have, okay? And that's why I said we get lazy, we stop writing the delta. If I want to find the acceleration, I need an equation that has an a in it. Well, you know what? This one. Now, this one doesn't have a distance in it. No, I gave you that just to throw you off. We can go like this. Acceleration is equal to v final minus v initial over t. Time is a scalar. It's going to be 9 minus 0 over 4.5. And you can probably do that in your head. 2, isn't it? Yeah. Probably should go to 2 sig figs, but I'm not going to be fussy. So 2 units, meters per second squared. Mr. Dewick, is that a very big acceleration? You know what? We're going to compare accelerations later on to what we call G's, the acceleration due to gravity. And the acceleration due to gravity is right around 10. It's about 9.8. This isn't that big. Although for a runner, it's not bad. Next page. So the standard unit for expressing acceleration is meters per second squared. So if an object is accelerating at 1 meter per second squared, that means its speed is increasing 1 meter per second each second. 1 meter per second per second. 1 meter per second squared, instead of saying per second per second. There is another way to measure acceleration. I'm not wild about it, but it shows up because of cars. So example 2, a UFO is spotted as accelerating from rest. You know what? I'd probably underline the phrase from rest. To 680 kilometers per hour in a time of 2 seconds. What's its acceleration? Well, wants me to find A. What does from rest tell me? What's 0? VI. What's that 680? Sorry? VF. And I noticed it's kilometers per hour, so I'll write the units down just to remind myself to be a bit careful. What's that 2.0? Looking for an equation that has A, VI, VF, and T in it. Well, right now we only have one equation. In a few days you'll have a bunch more, but for now I would write A equals VF minus VI over T. I'll get 680 minus 0 all over 2. You know what? I think I can do that one in my head. 680 divided by 2, 340? Yes? No, yes? Yeah. What would the units for this be? Well, this would be kilometers per hour per second, because the top is kilometers per hour and the bottom is seconds. This is another way to measure acceleration instead of meters per second squared. I'm not wild about this, so I wrote down here, the speed of the UFO is increasing by 340 kilometers per hour every second. So after 2 seconds, it's going to be going 680 kilometers per hour. After 3 seconds, it's going to be going 1,020 kilometers per hour. This acceleration might be written in the form of 3.4 times 10 to the 2 kilometers per hour per second, or 340 kilometers per hour per second. Kilometers per hour per second is not the officially accepted unit for acceleration, but it's often used when describing the acceleration of a car. Because what does your speedometer give you the units in? Yeah.
Could you not just convert kilometers?
You could, except I'm not going to, because it's accepted. So I wrote down here, Mr. Dewick doesn't like the unit, but he tolerates it because cars. In your homework, there's going to be 2 or 3 questions where I give you a speed in kilometers per hour, I give you a time in seconds, and if you glance at the answer, you'll say, oh, he wants it in kilometers per hour per second. I'm only going to really be doing that during this lesson. All the other times, to be honest, I'm going to convert everything ahead of time, Thomas. It does kind of make sense when you're in your car. You'd like to know, What's my kilometers per hour changing by every second? Okay. And you can read that from your speedometer. Okay. Other ways to write the acceleration equation. Get VF by itself. Let's write down our equation. I'm going to do some algebra here. I'm not worried about the vector signs and all that stuff because I'm just going to do some algebraic manipulation here first. Sharon, what does it want me to get by itself? Careful. VF. VF. Okay. Well, when you're rewriting an equation, you always do reverse bed mass. So first of all, see the VF? What's the VI doing to it? I'll get to that later. What's this big T doing here? Dividing by T on this side is the same as doing what with the T on this side? Multiplying. So we could go like this. Cross out the T and tuck a T right after the A right there, AT. You can write TA, but traditionally it's written AT, so I'll show it to you that way. We would have this. AT equals VF minus VI. Sharon, what did you say I'm trying to get by itself? There's a VI there too. See it, see it, see it, see it, see it? What's the VI doing to the VF? How can I move the VI over? What's the opposite of minusing VI? Adding. I'm going to push you to do, this is called formula manipulation. I'm going to really push you to get good at this. If you can do this, and you will because I'll make you, you'll cut down on your memorization by about 90%. And you'll cut down on your workload by about 50%. It's a win-win. It's a double win. It's going to be a bit weird. Some of you are going to be, I want to put numbers in. I'm going to make you do math with letters. It's easier. What did you say we're going to do with the VI? So I'm going to get the AT dropping down like a domino. You said I'm going to add the VI, and that equals VF. In fact, if you look on your formula sheet, it's written this way. VF equals VI plus AT. That's actually the equation that I gave you on your formula sheet. I gave you that one because most of you hate fractions, and this one has fractions and junk. But I always start out by defining acceleration to then derive that new equation. Also, that one that I just put a box around is easier to rewrite. It says get VI by itself for the next part. How would I get the VI by itself? Well, next to the VI, there's an AT. What's the AT doing to the VI? Adding, subtracting, multiplying, or dividing? Adding. How would I move the AT over? Subtract. So if I hear you correctly, you're telling me the VF would drop down like a domino and I would subtract the AT, and that's equal to VI? Yes? What if I wanted to get the time by itself? What if I wanted to get the time by itself? See the T, see the T, see the T? You know what? Let's start out writing this one here. Let's rewrite VF equals VI plus AT. I want to get the T by itself, Connor, my friend. How am I going to do that? Connor, on this side, Connor, what's the A doing to the T? Adding, subtracting, multiplying, or dividing? So how will I move it over? Do that last. Do reverse bed mass. What's the VI doing? Adding, subtracting, multiplying. How will I move it over? So, ready? The VF would just drop down like a domino. What did you say I'm going to do with that VI? Don't write this next, you can write that down. Don't write this next bit down. Instead, see it in your head. So in your head, Connor, the AT has just gone kuthump and dropped down. What did you say I'm going to do with that A? There's another equation. You can write that one down. How many different variables are there in this equation? 1, 2, 3, 4. How many equations does it contain? 1, 2, 3, 4. How many am I going to give you, Darcy? This one. But if you can learn to rewrite it, and in fact, I'm really going to push you to rewrite and do all this in your head, you don't have to memorize the other 3. That's not bad. We're going to come back to using these equations in a second, but I told you I'd give you a clever way that you can figure out acceleration direction. All of us have a built-in accelerometer. You can feel it when you're accelerating. You can. The only problem is your built-in accelerometer is what, Thomas? Who taught you that in Science 10? Maybe me? I did. I'll give you an example. I'm going to convince you of this. So when a car is stopped at a red light and the driver hits the gas, which way do you feel like you're getting pressed? But which way are you clearly accelerating? Forwards. Okay? You feel like you're accelerating backwards, that means you're actually accelerating forwards. Or when a car hits the brakes and stops quickly, which way do you feel like you're getting pressed? But you're slowing down, which way are you clearly accelerating? Right? How many of you been on the elevator at Playland or other rides like that? Okay, so remember that. When it shoots you upwards, first of all, which way are you clearly accelerating? When it shoots you upwards, which way are you clearly accelerating? Upwards, but which way does it feel like your stomach is being pressed? Or which way does your body feel like it's being pressed? So our bodies can detect acceleration. We have a built-in accelerometer, just backwards. It is. So if you're ever on a ride, or if I ask you an acceleration direction and you can imagine yourself sitting in whatever I ask you, ask which way would I feel like I'm accelerating? It's the opposite direction. When the elevator ride shoots you downwards, Luke, which way are you clearly accelerating when it shoots you downwards? But which way do you feel like you're about to fly? You grab you reflexively grab because you feel like you're flying off. You feel like you're going to fly up. Yes? E is Physics 12. The Music Express, that's the one that goes in a circle really, really fast. You guys want to go faster? Yeah! And they play music and it goes faster and faster and faster and faster and faster and faster and faster. Okay? Which way do you feel like you're getting pushed on that ride? Outwards. So which way must you be accelerating actually? Yep. When you're moving in a circle, your acceleration is actually inwards. That's very counterintuitive to people. We'll spend a whole unit looking at circular motion. It's called Centripetal Force in Physics 12. You all just turned to the page? Yes? At the top of the page, let's write VF equals VI plus AT. This is going to be our go-to equation. This is going to be the one that we're going to choose to rewrite whenever possible. It's also the one I gave you on your green formula sheet. Can you find where it is on your green formula sheet? In fact, I think it should be on a row of 4. Those 4 equations are going to be the big ones that we spend the next month and a half using. And this will allow us to handle free fall, car accidents, all sorts of nice stuff. This will allow me to jump out of an airplane. I mentioned I jumped out of an airplane? Because I did. All right, example 4. A car starts from rest. I would probably underline the phrase from rest, and accelerates at 4.5 meters per second squared for 3.6 seconds. How fast is it now traveling? What's this question asking me to find? Okay, anytime someone says V, you're going to hear me say, which one? What did you say, Patrick? I think it wants me to find VF, so I'm going to write down VF equals question mark. Then I'm going to go through the question. I'm looking for numbers and physics words. By physics words, stopped, at rest, slowed down, physics words. From rest, what's that tell me? What's VI? What's that 4.5? How do I know it's acceleration? 2 ways. First of all, they use the word, but I don't even look at the words. I glance at the units. It's meters per second squared, and I've taught myself as a quick little shortcut, whenever I look for numbers and the units, and I know what it is right away, it has to be the acceleration. I also did a quick double check. The units match my preferred ones. It's not kilometers per hour per second. What's that 3.6? How do I know? Seconds. All right. If I accelerate at 4.5 meters per second squared for 3.6 seconds, also you'll notice now we can handle decimals, which from the graphs we couldn't, or from our chart earlier, we sort of handled decimals, but it was yucky. I'm going to use VF equals VI plus AT. It's going to be 0 plus 4.5 times 3.6, which is what? 16.2 units. It's a velocity. Yeah, and that way, again, if you've memorized what units go with what concepts, I can't call it a no-brainer because you need to know the units, but it's almost a no-brainer. Meters per second. I tend to put a box around my final answer. That's like my touchdown, spike the ball dance. Okay. Thomas, this is example 5 is sort of the answer to your question. It says a car is traveling at 110 kilometers per hour when it hits the brakes and accelerates with a magnitude of 8.0 meters per second squared. How many seconds will elapse before it comes to a stop? By the way, I would underline the word stop because that tells me something. What's this question asking me to find? Let's write down t equals question mark. All right. What's that 110? V initial. What are its units? I may have to convert that. This was going back. You asked earlier, Thomas, why can't I convert? I will sometimes. I'm going to write this. VI, and because it's got suspicious units, I'm going to write the units next to it, and I'll even leave some space in case I need to do a conversion. What's that 8.0? And it's meters per second squared. I'll stick the units on there just to get my attention. This is not enough. What else do I know? Oh, what's V final? Oh, stopped. Okay. What do they want the time answer in? Then let's convert this VI. How do I do that? It has something to do with the 3.6. Do I times by 3.6 or divide by 3.6? Divide by 3.6. I'll write 30.6, but I'm going to keep this on my calculator, and I'll use my answer button. Okay? So I'm going to write 30.6. Well, first of all, I need to do this. Move over. Although I accidentally moved the stop underline, didn't I? There we go. So this will be 30.6 meters per second. I'm looking for an equation that has a T, a VI, an A, and a VF in it. Well, it's the one from the top of the page. Let's write it down. What do I want to find? I want to get the T by itself. How? First, I need to deal with the VI. Subtract it. Can you see it? Imagine it. Well, you know what? Let's write that down. It would be VF minus VI. And then on the right-hand side, don't write this down, don't write this down, just imagine it. There would be an AT that would ka-thump, drop down like a domino. What am I trying to get by itself? So how will I get rid of the A? What's the A doing to the T? Adding, subtracting, multiplying, or dividing? So how will I move it over? So write that down. And I'm going to put the t equals on the left-hand side because we're used to seeing the thing that we're trying to get by itself on the left. Okay. It's going to be 30. I'm going to write 30.6. I'm going to use my answer button. Minus 0 all over 8. Now, minusing 0 won't change the question, but is this a fraction? Is what I have here a fraction? Everybody say yes.
Yeah.
If there wasn't a 0, right? If there wasn't a 0 right here, I would have to put the top in brackets. Anytime you have more than one thing on the top or more than one thing on the bottom, you have to put it in brackets. Yeah. Ooh, did I do this wrong, Mr. Dewick? I did. 0 minus 30.6. Thank you. Candy for you. Zero minus answer button divided by 8. We're going to run into a problem. Pardon me? So what very subtle error did we make? Are we speeding up or slowing down? So is that going to be a positive acceleration or a negative acceleration? I should have put a negative there. Put a negative there. Now that's easy to fix because if I put the negative there, I'll get the same answer but positive. So I'm just going to temporarily ignore this negative, Mobeen, but it caught me. I like the fact that the universe is telling me, look, you can't slow down and have a positive acceleration. I'm going to give you a weird time to get your attention. So instead of negative 3.82, I'll go positive 3.82. And it's not acceleration, Mr. Dewick. Time. One more, we're done. A dragster starts out from rest. I would probably underline the phrase from rest. And it reaches a speed of 37.8 meters per second in 2.1 seconds. What's its acceleration in meters per second squared? Lyndon, what's this question want me to find? I know I caught you taking a bite, sorry. Acceleration, let's write down A equals question mark. Lyndon, what's that 37.8? Sorry? Which one? What's that 2.1? I need something else, isn't enough. What's 0? Okay. I'm looking for an equation that has an A, a VF, a T, and a VI. Well, it's the one from the top of the page. It's VF equals VI plus AT. And I know we wrote the A by itself earlier, but just so we don't have to look stuff up, so we can get good at actually just rewriting the equation that they gave me, how would I get the A by itself? How would I get the A by itself, folks? So I want to get this by itself. You go reverse bedmass, do the adding, subtracting stuff first. So that VI, what's the VI doing to the A? Adding, how will I move it over? So the VF is going to just drop down like a domino, and you're telling me I would subtract a VI from it? Is that okay? And then I want to get the A by itself. How will I move that T over? And that's the equation that we wrote way back when, where we defined acceleration. We said acceleration was the change in velocity, final minus initial, over the change in time, except I said time is always a change until we get lazy and don't write changing. And now we've reached back to plug and chug. It's going to be 37.8 minus 0 all over 2.1. 18 meters per second squared, which is about legitimate. That's that's just shy of 2 Gs. Dragsters accelerate pretty fast. Pretty fast. Okay. So this is our introduction to acceleration. What's your homework? I'm going to do number 1, and that's going to be the only kilometers per hour per second acceleration I'm going to give you. Number 3 is good. 4 is good. 5 is good, and 6 is good. We'll talk about 5 and 6 next class. Roller coaster or Tesla Model X. Since I took a Tesla for a test drive, I'm going to go with the Tesla Model X. I took one for a test drive a couple summers ago. Oh, there you go. California Screaming. So number 9 is good. 10 is good. 11 is good. 12, 13, and 14. So really I just skipped which one? 7 and 2? I skipped 7 and 2. 2 and 7. If you probably can get it all done in class, actually. I am going to say if you just write down an answer, I won't accept that. I need to see at least one line. So list your data. If you can glance at the equation and rewrite the equation in your head and just go to the new equation, I think that's good. I think that's good.